Okay, problem number 4. This is an example of one of our exponential growth problems. Again, kind of the culmination of the whole unit in this problem right here. We're told that the starting population of a bacterial colony is 237,000. After 15 hours, the population has grown to 357,000. Use the equation A equals P times e to the RT to answer the following questions. First, we want to find the rate of growth for this population, R, and then we want to use that rate to predict the size of the population after 2 days. And notice I say 2 days is 48 hours because we are going to get our rate based off of this number right here, 15, which is in hours. So we need to keep consistent with our units. So let's go ahead and get started. First off, we need to talk about this function, A of t equals P times e to the RT. Now, this is the function we use for all of the problems of this type. A of t is talking about the size of the population after t hours. P is the initial size of your population. E is just the natural number e. R is the growth rate that we're trying to find, and t is the number of hours. So let's start plugging in what we know. Well, A of t, we know that after 15 hours, the population has grown to 357,000. So A of 15, i.e. the population after 15 hours, we know to be 357,000. So that would be our A of t. So 357,000 equals P, our initial population, which in this case is 237,000. So 357,000 equals 237,000 times e raised to the power of RT. Now I don't know what R is. Again, that's what we're trying to find. But I do know that T is 15 hours because that's where that 357,000 came from. That is the population after 15 hours. So I have an equation here. Notice the variable I'm trying to solve for, R, is stuck up in the exponent right now, and that's why we need logs. That's what we use them for. We can get that variable down. So in order to use a log, first thing we want to do is simplify this equation a little bit. We want to get that e to the r times 15. We want to get that by itself. So right now we have 237,000 times that e to the r15. But we want just that e to the r15, so we got to get rid of that 237,000. Since it's being multiplied, we will have to divide both sides by 237,000. So do that, and we can simplify this to that fraction, 357,000 over 237,000. And some of you have been simplifying this, plugging it into your calculator and getting a decimal. You can do that, but really I would recommend just leaving it as a fraction because you're not always going to get a nice clean decimal, and sometimes you will get a decimal that goes on forever, and then you'll have to round, making your answer not as accurate as we would like. But anyways, let's keep going. We have solved this equation for that exponential part, which is what we wanted. Now, to get that exponent down, we have to take the natural log of both sides. So, take the ln of that fraction, 357 over 237. Notice all those zeros are going to cancel out. That's nice because power is a 10 in the numerator and denominator. That is going to equal 15r because, side note, ln of e is 1. And our product, our power property lets us rewrite that coefficient, 15 times r, as a coefficient. I said coefficient, sorry, 15 times r, the exponent, we can rewrite as the coefficient. ln of e is 1, so we just get 15r when that simplifies, which is awesome. Again, that's why we learned all those rules, so we could do that. Well, last step, we're almost done, but right now we have 15 times r. We need to solve it for r. So, divide by 15. ln of 357 over 237. That entire thing divided by 15 equals r. Notice that 15 is not in the fraction inside that natural log. You find that number, the natural log of 357 over 237, then you divide that by 15. So on our calculator, it's going to look like this. Of course, turn your calculator on first, and then we're going to start by hitting that natural log button, and then your screen will say ln with the parenthesis like that. Then just press 357 divided by 237, close the parenthesis, and then divide by 15. And you can do that all in one step, which is super awesome. Do that, and you should get the decimal 0.0273117094. And again, that's a whole lot more than we want to write each time. So go ahead and round this decimal to 3 decimal places just to stay consistent with what we've been doing. Round that off, and then you should get that r is 0.027. Now here's the thing. If you decided to use 4 decimal places or 5 decimal places or all of those decimal places or stored this as a variable in your calculator, which is honestly the best thing to do, you're going to get a different answer than if you use this rate with just 3 decimal places, because these exponential problems, exponential growth, grows so quickly that you will actually have a very different answer than if you use just these 3 decimal places. So keep that in mind. If your answer looks different than mine, maybe that's the reason. Maybe you didn't round the same way I did. But nevertheless, that is our answer for part 1. We found the rate. Now, the second part of the problem is asking us to use that rate and use it to predict the population after 2 days. Well, at this point, we are going to jump back to our equation, which was A of t equals our initial population, which was 237,000, times the natural number e raised to our rate, which is 0.027 times time, which in this case is 2 days. But remember, our units have been in hours so far, so we need to stay consistent with that. So our time needs to be 48 hours. Now again, this is just a calculator problem at this point. You just need to enter it into your calculator. To do that, it's going to look like this. You're going to type it pretty much just like you see it. So go ahead and type that 237,000. And then you see the next part of our equation is our exponential part, e raised to that power. Well, you have 2 options to do that. Your best option is to hit the second button right there, and then hit the natural log button. Notice above the natural log button, you can see in yellow or possibly blue on your calculator, depending on the color of your second button, that it actually says e to the x. So hit that button, and then your calculator will automatically give you e raised to a power. If you have an 84, it won't do the caret in the parentheses. It'll actually just put it in the exponent for you. But if you're on an 83, it'll look like this. Now continue forward with what we have. Well, now we need to raise it to our power, which was our rate, which was 0.027, and we need to multiply that by 48. And then close your parenthesis. That is very important. If you type this as all of that the same, but then you do 0.027, close it, and then do your times 48, you're going to get a different answer. So make sure that that 0.027 times 48 is in fact inside the parentheses all together. Do that, and then you should get your answer. 86, I can't do numbers, 866,151.767. And notice I rounded that already. Your calculator would tell you 0.7647. Oh, and now that I said that out loud, I totally did not round that correctly. So 0.765 should be your answer. And we're done. That's how all these exponential growth and exponential decay problems will work. If you can do that, you're solid.